In this video, we're going to talk about equivalent ratios. So ratios that describe the same relationship but might contain different numbers, such as 1 to 2 and 2 to 4. Okay, so to get to equivalent ratios, we, much like to equivalent fractions, we multiply both parts of the ratio by the same number. So in these ratios, we're multiplying both parts times 2 to go from 1 to 2 to 2 to 4. Okay, and so oftentimes our ratios are written as fractions, and so it's going to be very similar to how we found equivalent fractions, finding equivalent ratios. All right. So another example might be 10 to 15. Okay, I could multiply both of those numbers times, 2. And I would get 20 to 30. Okay, I also could have taken the 10 to 15 and divided it by 5 to find the equivalent ratio of 2 to 3. Okay, and this 2 to 3 is actually what we would consider simplest form of our ratio, just like we would consider it simplest form of a fraction, because 2 and 3 don't share any common factors other than 1. We can't divide them both by the same number and get whole numbers still. Okay, so those are equivalent ratios, similar to equivalent fractions. I'd say the only other thing that we might need to be able to do is determine if two numbers or two ratios are equivalent. Okay, so if I ask you, is the ratio 2 to 5 equivalent to 8 to 20? Well, to figure this out, we can see, okay, what do we have to multiply 2 times to get 8? Well, we have to multiply it times 4. And so I check and see, if I multiply 5 times 4, do I get 20? Yes, so those are equivalent ratios. Okay. However, sometimes we will be given two ratios that can't be multiplied to get to the other one. So let me show you an example of that. If we have something like 2 sixths and 5 15ths, we're trying to figure out, are those equivalent? Well, I can't multiply 2 times a whole number to get to 5. I could figure out if potentially there's a decimal or a fraction to multiply it by, but instead what I'm going to do is I'm going to write both of these fractions into simplest form. Okay, so I'm going to rewrite them here. So 2 sixths, and I can divide both 2 and 6 by 2. So I'm going to divide by 2, divide by 2, I get 1/3. Okay, and then I'll do the same thing with the 5 15ths. I'll try and divide 5 and 15 by the same number to get it into simplest form. So I can divide both 5 and 15 by 5. If I divide them both by 5, I get, once again, 1/3. So if our simplest form fractions are the same, then our original ratios were equivalent. Okay, so that's one strategy that you can always use to see if two ratios are equivalent, is to automatically bring them down into simplest form. And if the simplest forms are equivalent, the original ratios were equivalent. So that's what I would recommend doing if you can't do something like we did above, where we can easily take one of the ratios and multiply it by some whole numbers to get it to equal the other ratio. Testing that simplest form is going to work every time.